We're in the final portion of the course where we're talking about something known as statistical inference. That means we take information from a subset of a population called a sample, and we use that information to infer something about the population. Now, just to keep things concrete, we're going to focus on the population parameter known as the average, mu. Now, what we had talked about before were confidence intervals. So we take a sample, we use info from the sample to form an estimate of the value of mu, and then we take the probability tools to give a margin of error or some sort of estimate of the confidence in our guess. But there's another type of procedure. So in this other statistical inference procedure, what we're doing is checking the validity of a claimed value of mu. So for example, somebody could claim, well, I think the population average is 5. Should I reject this claim or not? And this type of test, this type of procedure is known as a hypothesis test. Hypothesis test is essentially a statistical method to determine whether or not we should reject a claimed value of mu. And it's not just some arbitrary test. It depends on what we call evidence or statistical evidence. Now, there are some important ideas here, and I think the best way to get them across is to talk about a good analogy. And I think the analogy here is a court trial. In a court trial, a person is accused of something. So there's a claim. Now, that person, they are either innocent or guilty. But the trial's purpose is to gather evidence and then for the jury to make a decision. And the decision is, should we acquit the accused or should we convict? So there are 4 things at play here. There is the truth of the matter, either the person is innocent or guilty, but then there's a decision that is made about whether or not to accept or reject that claim. And I should be a little bit more careful and put it in the context we're going to use, reject or not reject. Either the person is innocent or they're guilty. So if they are innocent, you could then correctly acquit them of the crime. So the decision you make is in fact the correct decision. They could be innocent, but you could make the wrong decision and convict them. Now, the person could be guilty, and you could again make the wrong decision and say they're innocent, acquit them of the crime. So again, the only action you can take is to make a decision about what to do. And then finally, they could be guilty, and you could see the evidence and decide to correctly convict them. So the point of the story here is that we can never really know the truth of innocent or guilty. Right? That is unfortunately information that we never usually know in a trial. You can only take action in the following way. The action that you can take is to make a decision based on evidence. Should you acquit them or should you convict them? This is it. So your action item here is a decision. You will never know the truth, but you have to gather the evidence and try to make the right decision. So in this particular case, that would be the right decision, and this would be the right decision to make. Now, in the context of statistics, the court trial is called a hypothesis test. And the action that you need to take is that you have to make a decision. Either you reject or you do not reject a claim about mu. And you do this by gathering statistical evidence. The evidence is what you use to help make a decision. The only action you can take is whether or not to reject the claimed value. There is a difference between not rejecting something and accepting. It doesn't necessarily mean you believe in it. It's just that you can find evidence to say that you're going to reject it. So you could suspect somebody of being a murderer, but you don't have the evidence to say, I'm going to make a decision to throw you in jail. That doesn't mean you accept that they are not a murderer. It's just you don't have enough evidence to say that they are. We will say this. We will say that the null hypothesis is given by the symbol H subscript 0, 0 for nothing, for null. And this is the claimed value of mu. And this is what you are trying to reject. And it's usually the opposite of what you think is true. So the null hypothesis is it's a claim about the value of mu, and it will turn out that the null hypothesis is what we are going to try to find evidence against. Now, the alternative hypothesis we are going to state as HA is what we believe is true about the population average. Now, hypothesis tests are kind of strange. We can't ever find evidence in favor of our claim. Only evidence against the other claim. And that's kind of weird, and I will show you how the idea works. So, another way of thinking of the null hypothesis is kind of the status quo, no change. That sometimes helps understand what it's about. In the PDF file that I've got here, I've got some examples of trying to identify the null and alternative hypothesis. So the first one here is the example with the pretzels. And in the example with the pretzels, a company is selling essentially 1 pound bags, 454 grams, and they want to make sure that the machines are working properly. So they take samples of the bags and they measure the mass. Okay, so in every hypothesis test, we need to have two claims, two statements. There's the null hypothesis, the no change, that everything is working fine. And so the null hypothesis here would be 454 grams. Everything's great. The alternative hypothesis is the machine is broken. So in this case, the machine works properly in the null hypothesis, and in the other case, something's wrong. Now, we don't know how something is wrong, but all we can say is that the machine does not work properly. We are going to call this a two-sided alternative. And the idea here is that we have taken all the possible values of mu. We've taken the whole line, the number line of mu, and we have partitioned it. We have partitioned it into two parts. One of the parts is the null hypothesis, where we say H naught has to be this. And then the other two parts, or the other portion, is the alternative. Everything else but that. So in this partition, you are either, mu is either in this null hypothesis or it's in the alternative. You can't be in both at the same time. So it's one or the other. And that's an important idea, because what we're going to try to do is show you that it's not possible to be in the null, so therefore you must be in the alternative. Now another example here is the books example. And so the mean price of a history book is given, and the company wants to know if the price has increased. So to help you try to formulate these things, I'm trying to give you these tips. The null hypothesis is always the no change. Nothing has changed. So if nothing has changed, then we'll say that the null hypothesis is $51.46. The alternative is what you suspect is the case. Now, in this particular problem, we suspect that the prices have increased. So we will say that the true average price is $51.46. Now, to get things working in the partitioned idea, this we're going to consider to be a one-sided alternative. Now, mathematically, what we are trying to do is partition all of the possible values of mu. So, in this example, when I say that the null hypothesis is 51.46, we start with that as a starting point. But in actuality, we are going to take the null hypothesis to be everything less than or equal to. So the null hypothesis is there, and the alternative is here. And what we have done is partitioned. All of the mu values here are partitioned into a union. All right? The mu values are found either in H naught or in HA. Now, this case was a one-sided alternative. You can certainly have a one-sided alternative in the other direction, and the point is the same. What we are trying to do is partition or split up all the possible values of mu. That is the key logical underpinning to the next step here. So in the next step, we're going to take an example, formulate the alternative and the null, and then try to show the process of evidence gathering so that we can show, look, the null hypothesis should not be believed, or we should reject it. And because we have partitioned everything, the only other option for mu is to be in the other portion. So we will talk about that in the next video.